Hello, students. Good morning to all of you. Good morning. Hope you all are doing well. I can see very few are there. Am I clear to you? Can you see me clearly? Am I audible to you? Is it clear? Just comment once. You can see me or okay. If you are able to see me, okay. But am I clear? Means you are seeing it clearly or it's blur? It's clear or blur? Okay, and I hope I think I'm audible to you. Okay, clear, fine. Okay, thank you, clear. So come on, join first so that we can start. And as you know, this is the second session of the chapter sound. Sound we started in our last live session. Chapter sound we started, and we'll continue this chapter sound. Okay. Okay, Pratham is saying, yes, sir, it's clear, it's visible, it's audible. So, Pratham, okay, I am visible, but you don't get invisible. Huh? You become invisible after some time. Don't do that, Pratham. Okay. Fine. So, this is the thing. Now, join first so that we can start the chapter, the next part of the chapter called sound. Okay. If you remember, that day I discussed about that Pratham's home, nobody's there. Okay. If you remember, Pratham's home, nobody's there, then Pratham started vibration. So all the object in this world, okay, all the object in this world wants to be vibrate in their own natural vibration. Okay. All the object in this world wants to be in own vibration. Okay, that is called natural vibration. Okay, but natural vibration is not possible. You start vibrating naturally, natural vibration, but after some time your parents comes. Okay, so there is a restriction and you have to stop your vibration. Understood? Same way, when you have vibrated something, say this is the register, and by this pen I made sound. You heard this sound, means the registers has vibrated. You heard the sound, means register has vibrated, but this vibration didn't continue. You made the sound and that got over. The vibration didn't continue. Why the vibration did not continue? Because air and other restriction is there which is forcing it to stop. That is called damped vibration. We discussed that day. So this figures you have to remember. The first figure is the first graph I told you, natural vibration, you remember? Natural vibration. Second is, yes, second is damped vibration. Damped vibration, it will reduce. Okay, it will reduced. Then what I discussed, Nilesh Vishwas has come. Nilesh, did you get the notification today? So what I discussed that day also, that wavelength I discussed, amplitude I discussed, frequency I discussed. Are Nilesh Devi says you have not got this. Hurry, how come? Maximum time you are not getting notification. Others got the notification. Who has not got the notification? What I told you that Sneha, you have not got notification. Sneha also not got the notification. And then Nilesh De Viswas. Okay. You two have not got notification. Pratham, you have got notification. Pratham, did you get the notification? Okay, Pratham got the notification. Fine. Thank you. So, what I discussed that day I discussed about wavelength, amplitude, frequency, complete vibration, oscillation. Okay, sir, got it after opening YouTube. Okay, after opening YouTube, you got the notification. Okay, so this is what I discussed, and I discussed about natural vibration, then damped vibration, forced vibration. Forced vibration, you remember? Forced vibration means you are forcing something to vibrate. You are forcing something to vibrate. Okay. So this is the register. I forced the register to vibrate. That's why you made sound. Okay. Forced vibration. Okay. Then resonance I discussed. You remember that day when Pratham was alone at home, he was enjoying. Then he called Sahil. Sahil joined. So Pratham was also vibrating. Sahil was also vibrating. Both were happy. So their vibrated matches, their vibration matched, and their vibration, yeah, the vibration was more stronger. And we called it when two vibration was matching, when two vibration got matched, then you get more sound, and we call it, what name I gave? Can you write in the comment what name I gave it? When Pratham was vibrating, Sahil was also vibrating in the same way, then you are getting more sound. So what vibration? Yes, Karan Mitra, send me the answer. Resonance. Yes, we called it resonance. Very good, very good, very good, very good. No, not forced. It's resonance. Very good. Pratham has also answered. Good. Resonance. Now, if you remember, I told you, if you remember, I told you that uh, V is velocity of sound. V is velocity of sound. And if you remember, I told you that Pratham is shouting, and but I am quiet. Means I am talking, but very softly, very slowly. But Pratham is shouting. So whose sound speed is higher? I asked you that question. Pratham is shouting, and but I am talking very softly. So whose sound speed is higher? No one's. Yes, we have equal speed of sound, because sound speed depends on, yes, sound speed depends on the atmosphere, on what atmosphere we are sitting. Both sound have same velocity. Yes, Sahil Sharma said it correctly. Both sound has the same velocity, because we both are sitting together. Both are sitting together. Very correct. Very good. Now, so this is what. Now, shouting means higher amplitude. Low sound means less amplitude. Okay. Now, one more question. One more question, all of you. Do you think, one more question you have just answered me. Do you think there is a difference between my sound and Lata Mangeshkar's sound? Do you think, is there any different, or they are same? Like my sound and Lata Mangeshkar's sound, they both are different or same? You're saying it's different or same? Yes. They are different. Both the sounds are totally different. Both the sounds are totally different. Vast difference, correct? Sneha saying vast difference. Yes, vast difference. Because nobody can compete Lata Mangeshkar. Nobody. You know why? That is called frequency. My sound has very low frequency. My sound has very low frequency. But Lata Mangeshkar's sound has very high frequency. Not only that, I can give you an example. Another example, like the voice of boys and girls. Boys versus girls, if you see their tone, their voice, you will see that in case of boys, it's so mota type of voice. But in case of girls, it very patla voice. No, boys have so mota voice, go type, and but girls have very thin voice, teeny type, like that. Understood? Why? Because girls' voice has high frequency. Okay, girls' voice has high frequency. But our boys has very low frequency. That's why our voice is so motu type of voice, boo type of voice. Okay, so our frequency and girl frequency is much higher, and boys frequency is less. Okay, so you know what, if a sound, you know this, you have done it in your previous class also, if a sound has frequency 20 hertz to 20,000 hertz, then only the sound is audible to you. You understood what I said? I said, what means the sound will be audible to you if the frequency is 20 hertz to 20,000 hertz. Okay, if the frequency of a sound is below 20 hertz, like 18 hertz, 17 hertz, then you won't be able to listen it. If the frequency of a sound is more than 20,000 hertz, then also you won't be able to listen it. Okay, so if I ask you this question, what is the audible range? Yes, Pratham said inaudible, correct. If I ask you this question, what is the audible range of human being? What is the audible range of human being? You will answer me 20 hertz to 20,000 hertz. Got it? 20 hertz to 20,000 hertz. This is called audible range. You know this. You know this. Now, so now if I ask you that my sound and Lata Mangeshkar's sound, you draw the graph of both the sounds. My sounds graph and Lata Mangeshkar sounds graph. I will show you both the graph now. Okay. After that, you will also draw it. First, I'll say you my sound. My sound is very low frequency, very low frequency, like this. My sound. After that, I'm drawing Lata Mangeshkar sound. Then I'll show you. After that, I'll show you. You will also draw it. First of all, you answer me. Is it clear to you? Can you see it clearly? See, this is my sound. This is low frequency. This is low frequency. And this is very high frequency. This is very high frequency. Okay. See, in this low frequency, see the graph of low frequency. And this is high frequency graph. See. Okay. High frequency graph. All of you draw it. And right here low frequency, right here high frequency. Low frequency, right high frequency. Must mention the name. Are Nilaj Vijay is now is getting this. Say, low frequency and high frequency. Okay, low frequency and high frequency. I hope you have drawn it. Now, if I see the amplitude, amplitude is the, I told you amplitude. What is that amplitude? If you see, in this case, amplitudes are same. Amplitude are same. Amplitude same. Wavelength. Wavelength are not same. wavelength not same. Not same. In this way, you have to also write. You will also have to write. See, this is the amplitude wavelength. I told you that day wavelength is the distance between top to top or bottom to bottom. I told you. So wavelength are not same. See, wavelength is bigger, wavelength is smaller. So wavelength are not same, but amplitude is same. This is called amplitude. This is amplitude are same. Okay, so this is the property of low and high frequency sound. All of you draw the graph and also write all this information. Also write all this information. Right here, low frequency sound, high frequency sound. Draw these graphs and write these informations. Okay, I hope you have done. So what I told you, high frequency sound means Lata Mangeshkar sound, high frequency sound. Low frequency sound, my sound. Low frequency sound, Mota sound. So in both the sound, amplitude are same. Amplitude are same, but wavelength are not same. Girls sound are very patla sound, surila sound. They have got high frequency sound, but boys have got very mota sound, low frequency sound. I hope you understood this. Now, I hope you understood and you drawn it also. Fine. So last class, in our last live class, I told you that Pratham is shouting beside me and I am also, I'm talking very softly. Pratham is shouting, I am talking very softly. So now we will draw the graph of both these sounds. Sound made by Pratham, which was very shouting, loudness, high loud. But my sound is, I'm talking it's very softly. So my sound is soft sound and Pratham loud sound is loud sound. Okay, I'll draw the graph of this soft sound and loud sound. When you are talking very slowly, dhire dhire, then it is soft sound. But when it is shouting, when you are shouting, it is loud sound. So what is the graph of this? See, soft sound and loud sound. These graphs are very important. I'll ask you these graphs in the exam. Soft sound and loud sound. See, all of you try to understand. Can you see this? Is it clear to you? This is soft sound. Soft sound, see, soft sound. And loud sound. See, loud sound. In soft sound, amplitude is small. But in loud sound, amplitude is higher. Okay, amplitude is higher. So here we can see that. Try to understand. Here we can see in soft sound and loud sound, wavelength is same. Wavelength is same. Try to understand. See the wavelength. Wavelength. They both are same. But amplitude are not same. Soft sound and loud sound, try to understand. Soft sound and loud sound, amplitude are not same. Loud sound means amplitude is bigger. Loud sound means amplitude is bigger. So amplitude are not same, but the wavelength is same. Like this, just opposite of this one. Opposite of this. Soft sound and loud sound. So come on, draw these figures, draw these graphs. And right here, wavelength are same, amplitude are not same. Write it. Write it, all of you. Okay. So we discussed loud sound, soft sound. Loud sound, soft sound means amplitude are different. Loud sound means amplitude is higher. Understood? Loud sound means amplitude is higher, and soft sound means small amplitude. Okay, but wavelengths are same. But in the first case, when we discussed high frequency and low frequency sound, in that case we saw wavelength was different, but amplitude were same. Okay. Now we'll discuss two different sound. So try to understand, all of you. Try to understand. So we saw different frequency sound and different loud sound, soft sound, where we saw that either amplitude is same, wavelength is not same, or wavelength is same, amplitude is not same. We saw that. So in that way, I'll discuss now two sounds with same amplitude, same wavelength. Understood? Two sounds with same amplitude, same wavelength. Then you may think that both the sounds are same. Yes, both the sounds are same in terms of their amplitude and wavelength. But when you will hear those sounds, this you can differentiate between those sound. Understood? Two sounds with same amplitude, same wavelength, but still you will be able to differentiate between these sounds. Okay, that is called quality or timbre. Write it. Quality or timbre. These graphs are very important, as I am telling you. Quality or timbre. Now, how will you draw this graph? See, quality or timbre. Quality or timbre means their amplitude and frequencies are same. Since though their frequency and amplitude are same, but still you will be able to differentiate that. You will be able to differentiate those sounds. Okay. Now, what is the graph of those sounds? See, I'm drawing the graph of those sound. See, quality or timbre. Quality or timbre. See here, this is the amplitude and this is the amplitude. Both are same. Wavelength, both are same. So wavelength, both are same. Amplitude, both are same. Draw it. So what I told you, that frequency, high frequency, low frequency, then loud sound, soft sound. But in those sounds, either amplitude is same, wavelength is not same, or wavelength is same, amplitude is not same. But this is what we have discussed now, quality or timbre. So if I ask you in question, quality or timbre, draw the graph. Then you have to draw these graphs. Okay, these two graphs you have to show in the exam paper. Okay, these two graphs you have to show in the exam paper. So what are the things? The thing is, their amplitude is same, the wavelength is same. Though their amplitude and wavelength both are same, but still you will be able to differentiate between these two sounds. Correct? This is quality or timbre. Now say someone is singing. Okay, someone is singing. It's so musical type of sound is coming out. Now say in a classroom, teacher is not there, then students are just shouting. Okay, so two examples I'm giving you. First example, a person is singing, so surila sound it's making and is singing, surila singing. Now in the other side, one classroom is there, teacher is not there. So what students are doing? Shouting. Now, do you think that their graphs will be different? Do you think that graphs will be different? Yes, will be different. The first one is musical note, and second one is noise. Musical note and noise. Okay, so what is the graph of musical note and noise? I will show you that. Musical note. I'm showing you musical note and noise. See, musical note and noise. This is musical note. So nicely the graph is going, but this is noise. So disturbed type noise. So musical note, noise. Draw this graph, all of you. Is it clear to you? Can you see this clearly? Draw it, all of you. Musical note and noise. Musical note and noise. Draw it, all of you. Okay. Okay. So this 4 type of graphs I have shown you. 4 types of graph. The first graph, low frequency, high frequency sound. Second graph, soft sound, loud sound. Okay. Third graph, quality or timbre. Fourth graph, musical note and noise. All these 4 graphs you have to remember. Okay. Now, if you remember, that day I shown you, we made a chart also that day. That day we made a chart also. I told you that v is the velocity of light. Okay, v is the velocity of light. And acha, where is Pratham? Pratham is there. Pratham, if you are there, just comment once. Pratham, if you are there, just comment once. Pratham, Jasraj, just comment. Pratham and Jasraj, just comment. Pratham and Jasraj are not there. Oh, Pratham is there. Jasraj is not there, I think. Jasraj is not there. Is absent. Okay. So we made a chart that day. The chart is v is velocity, and what is that? V is velocity. Then lambda is wavelength. Nu is frequency. We discussed that. I'll show you 2 relations now. Okay, 2 relations I'll show you, and depending on that relation we will do the numericals also. Okay, write these 2 relations. V equal to nu lambda. V equal to nu lambda. V equal to nu lambda. Jasraj is absent. Okay, V equal to nu lambda you have written, and write nu equal to 1 by t. Nu equal to 1 by t, capital T. V equal to nu lambda, nu equal to 1 by t. This one. Nehadev and Priyansh Kumar, are you there? Nehadev and Priyansh Kumar Thakur. Nehadev and Priyansh Kumar. Priyansh, are you there? Priyansh. So these are 2 equations. All of you write. V equal to nu lambda and nu equal to 1 by t. Okay, nu equal to 1 by t. These are 2 equations. So V equal to nu lambda. V is velocity, nu is frequency, and lambda is wavelength. And nu equal to 1 by t. Nu is frequency, t is time period. Got it? So in this way, two equations. These two equations are important to have the numericals. Okay. So let us do some numerical. This question comes that what is the relation between frequency and time period? Then you have to write nu equal to 1 by t. And it is comes that what is the relation between velocity and wavelength? Then you have to write the first equation, v equal to nu lambda. And if it comes that what is the relation between velocity and frequency, then v equal to nu lambda, same. Okay, these two equations you have to. Okay, now numericals will do in next day, next live session will do all the numericals. So many numericals are there in this chapter. We'll do all the numericals in our next class, not today, but equation you must remember. Okay, the next is the way we the next information, the way light reflects, the same way sound also reflects. Do you know? The way light reflects, the same way sound also reflects. Okay. But to reflection of sound, for reflection of sound, a large space is required. Okay. For reflection of sound, large space is required. That is called, that means sound also reflects. Okay, sound also reflects light, or like light. Sound also reflects. Now, we'll understand two important things. Okay, loudness and intensity. Okay, loudness and intensity. These two sounds, these two terms we'll discuss now. What is the meaning of loudness and intensity? Try to understand. Say, just imagine that you all are sitting in class 10A. Understood? All the student of class 10 are sitting in class 10A. No teacher is there. What class 10 student will do? All the class 10th students are sitting in class 10A, but no teachers are there. Okay, no teachers there. Then what class 10th student will do? Will they keep studying, or they will just shout? Yeah. Okay, sir party. Okay, so when all the students of class 10, they are student, all the students of class 10 are sitting in 10A, and 10A they are sitting. Okay, and no teacher is there, so they are just making noise, party, everything they are doing, shouting. Fine. Now just imagine that the wall is not there in between 10A and 10B. Between 10A and 10B, the wall is not there, and you are standing in 10B. One of the student is standing in 10B. That means you understood my case. What I told, the wall between 10A and 10B is not there, and one student is standing in 10B, and what he's getting all the noise. The whole noise is coming to him. Okay, the whole noise is coming to him. He's getting all the noise. Okay, this is called loudness. Understood? This is called loudness. Okay, so when all are shouting, and someone is standing at a distance and he's getting all the noise, we call it loudness. Okay, now imagine that the wall between 10 and 10B is there. The wall is there now. Just imagine wall is there. But in that wall, a window is there. Window whose measurement is 1 by 1. A window is there of square shape of side 1 meter. Understood? 1 meter, not 2 meter, 1 meter. Okay, a square shaped window whose side is 1 meter. Now how much noise he will get? Now how much noise he will get? So first I told you loudness. So first I told you loudness. Loudness means you are getting the whole noise. You are getting the whole noise. That is called loudness. After that, we made a wall between that, and in that wall we made a square shaped window. Square shaped window. And what is the side of that window? 1 meter. Square shaped. Okay. Now you are getting the sound. How much sound you are getting now? That is called intensity. Okay, so first is loudness, then is intensity. Important, don't forget. Don't forget. Got it? Now what I was saying you that sound also reflects like light. Okay, sound also reflects light. So reflection of sound is important. We'll do the numericals based on all this sound. After that velocity, then all this will have but will all this will have in our next class, and most probably in the next live session we'll be able to finish this chapter. Tomorrow I'll take another live session, and most probably tomorrow we'll be able to finish this chapter. Most probably, not sure yet. Most probably, not sure yet. Okay. Fine. So we'll keep this much for the day, and we'll continue in our next live session tomorrow. Another live session will be there. In that live session we'll do the we'll do numericals based on all this theory. Okay, till then, bye bye. And now all of you just write your name, then you can leave the class. Okay, just write your name in the comment section, then you leave. Right. So tomorrow, right? Tomorrow we'll continue this. Thank you, all of you. Thank you. Thank you. Thank you.